Okay, short video here for geometry on the perpendicular bisector theorem that hopefully you have read about, that were in the instructions. If you're following along, I'm on page 303. Just going to do a real brief example, touch base on it, and that should be plenty for you to be able to do the problems that you're asked to do tomorrow when I'm gone. Perpendicular bisector theorem basically says if I have any segment, doesn't matter how long it is, but any segment on a plane, okay, if I would draw the perpendicular bisector to that segment, well, perpendicular bisector means it has to do two things. Okay? It has to bisect it, so in other words, cut it in half, and perpendicular means it makes a 90-degree angle with it. So if I would say that this line right here we'll say that line L, this is line L right here, we'll say line L is the perpendicular bisector of segment AB. Not only does it make a right angle, but it also cuts it into half. So it's perpendicular and it's a bisector because it cut it into two equal parts. Okay? So if you have a perpendicular bisector of a segment, you can pick any point on this segment and it would be the same distance away from A as it is B. So if I would just randomly pick this point right here and call it C, this distance right here from C to A and this distance from C to B, they're exactly the same. So I could put one tick mark through either one of them. Okay, they're exactly the same length. I could pick a different point. Let's say I pick a point down here. Let's call it point D. The distance from D to B and the distance from D to A, that would also be the same. Okay? So any point you pick on this perpendicular bisector, the distance from that point to the segments, the original segments endpoints, will always be exactly the same. Okay? So that's the perpendicular bisector kind of in a picture form. The converse is also true. If you know that point C is equidistant from A and B, so if you know that point C is the same distance from A as it is B, then you know that point C is on the perpendicular bisector. That's kind of the converse of it. You read about that as well. Okay? Real brief example that you'll probably get some sort of segment drawn. Then they'll say that this is the perpendicular bisector of it. And then they'll pick a point on it. I'll just use different letters here for right now. And then they'll give you two lengths like 2x plus 3 and 3x plus 1 or something like that. Well, what you can do to solve for x is, because point B is on the perpendicular bisector of AC, you know that B is the same distance from A as it is C, so I can set 2x plus 3 equal to 3x plus 1, and then you can solve your equation for x. Subtract 2x from both sides, subtract 1 from both sides, and you get x equals 2. If it said find the length of each segment, you could plug 2 in here, so 3 times 2 is 6, plus 1 is 7, 2 times 2 is 4, plus 3, that's also 7, so you can say that AB equals 7 units long. You could say that BC equals 7 units long. And that's really kind of all that you need to do on most of those problems for tomorrow. That should be enough to get you by. Hopefully you can complete all those tomorrow.